All right, today we're going to finish our notes that we didn't get to finish on Monday because of all this testing and field trips. It's really put us behind this week. So we're starting with question number 6, and we're going to continue to use the rules. So let's review. When you have a multiplying problem of powers, you have to add the exponents. When you have a dividing problem of powers, you have to subtract the exponents. And when you have power to a power, you multiply the exponents. So let's go through these examples and look at how does that relate with E. Because we've done it with the problems where we have letters as a base, but now we're looking at E as a number. How do you work that? Well, first of all, this is a multiplying problem. So we're going to add the exponents. So we're going to say e to the 2x plus 3 plus 3x plus negative 4. We're going to add all the exponents. So 2x and 3x are like terms. That makes 5x. Then you do the same thing for the constants. 3 and negative 4 make negative 1. Now, we don't move anything in these problems down to get rid of a negative or anything because we don't know how the x is affecting it. And so we just work these questions and leave everything where it is. So like in number 7, I'm not going to move anything down just because that 3's got a subtraction sign on it, for example. All right, first we work with the coefficients. And with the coefficients in number 7, you're looking at, can I divide them or reduce them? First, I'd think, can I divide 36 into 27? No. But 27 and 36 are both divisible by 9 to make 3 over 4. Then for the E part, because this is division, you subtract the exponents. So what is e to the 5x minus this whole expression, 2x minus 3? Well, first of all, let's talk about, let me move my 3/4 down a little bit. Let's talk about why did I put that in parentheses? Because I need to subtract all of the bottom. And so that's going to make it e to the 5x minus 2x plus 3 when you distribute the negative. And so when I add the like terms, I get e to the 3x plus 3, and the reason it's on the top is because I did top minus bottom. And in all of these problems, you always do top minus bottom. Now, in our next one, we've got a negative power on the outside. This is a time in which you would want to do that. So, I can't get my marker to right. We're going to move the whole thing down so that power on the outside becomes a positive power. Now, we're not going to move e to the negative 2x up to get rid of that negative because that's got an x on it. If the power has an x on it, you can't move it. It has to stay where it is. Now we're going to distribute negative 4 to the 4th power, e to the negative 2x to the 4th power. So we can do each one individually. For coefficients, you're just going to work it out on the calculator. So negative 4 to the 4th power is 256 because 4 times 4 is 16 times 4 is 64 times 4 more is 256. And I could just work that on the calculator. But with my powers having a parentheses between them, I'm going to multiply those powers because that's the power to a power rule. And that's going to make e the negative 8x. And it stays on the bottom because it was on the bottom before I multiplied the powers together. I do not move that up to try to get rid of that negative on the 8. The last two questions I have don't exactly relate to these power rules, but relate to radical rules. So first of all, this is a square root. So we're going to individualize this, the square root of each one individually. Whoop, got a little too close there. And over here, I'm going to talk about setting this one up at the same time. This is a cube root, and we're going to put a cube root on each one. Now for the number part, we can get that in the calculator. We all know the square root of 144 is 12. But if you didn't know the cube root, then you would want to go to the math button and use number 4 for cube root. And if you have an 84, the number 5 will do other roots. And if you press number 5, it puts a place up there for you to back up and put your exponent, like if you want a fourth root. If you're using 83, you have to type that before you hit the root number under math. But if you're doing a cube root, you just go right into doing 4, and it'll put the box up for you to put the cube root in on the 84. So the cube root of negative 125 is negative 5. So you go type that in the calculator and get that. So now let's talk about how do you do it with letters. Now E really isn't a letter. E is more like a number. But we treat it like a letter in this case because we want to keep it E. We don't want to get some decimal for this. We want exact. Now, if a cube root has a 3 on the outside, I wonder what a square root should have on the outside. Well, since a square root is the opposite of squaring, it probably would have a 2 on the outside. But they just don't write that 2 out there because it's understood to be a square root. But you need to write it because it's going to help you to do the math. According to radical work, you can turn these into fractional exponents. You can make that into 8 divided by 2 because it looks like a long division symbol. A radical kind of looks like a long division symbol. So you're taking the outside power and dividing it into the inside power, and same thing on the x. You're going to do 12 divided by 2. So that's going to make 12e to the 4th x to the 6. So if I do that same thing over here on my cube root problem, I'm going to have e to the 6 divided by 3 and x to the 12 divided by 3. So that gets divided out to make e squared and x to the 4th. And we leave it like that because we want the answer to be exact. Even though e is a number, you don't want to go e squared because it's not a nice number. The only e that ever comes out nice is e to the 0. So now you will be able to bring up the 4.1 worksheet and finish from 34 to 44, which allows you to get some example practice with this. Now remember, if they don't have an exponent on it, you can put a 1 up there for an exponent. If the radical doesn't have a number on the outside, you can put a 2 on the square root, and that'll help you to have something to work with.